All right, what's up, ladies and gentlemen? My name is Mr. McLogan, and tonight is another open live Q&A. I say tonight because I was not able to go live earlier, and I wasn't able to go live last week and the week before that. That is the problem with my life as it currently stands. And every single time you're going through, different phases in your life, you're going to have different struggles, different things you're going to, have to kind of overcome. And one of the hardest parts about my life in this point is being able to manage the time with focusing on the YouTube, but then also having family time on the weekends. And for those of you that have been on this channel, you know that I go live or I've been going live for over 4 years now. It's been pretty crazy. And so usually Sunday was always that day I love to go live, answer your guys' questions. And also that was my day for grading papers when I was still a teacher. But, times change. You have kids and then their time is demanding on the Sunday. So I do apologize for that. And there was also something special that I wanted to make sure that I had ready for this live stream. And that was to go through your questions and have them actually inputted on the document. So if you notice on the annotation above, that is the brianmclogan.com/Q&A. If you have a math question, I still want to go through and do as many math problems as I possibly can. The problem with being able to do them, um, in as far as on real time, it just becomes difficult. And then a lot of times the live streams goes longer than it needs to. And then my wife has texted me like, what are you doing? Why are you on a live stream for an hour and a half or 2 hours? So I am going to try to be a little bit more diligent with the time and also make sure that I can, pull out some questions and have everything displayed and ready for you to go. However, if you'd like for me to answer a question or go over a problem for you, then go ahead and submit it onto there. And also one thing that I've been doing is also posting some of those on my main channel as well. I won't do the shout outs on the main channel, but whatever you do post on that form, I will go ahead and put in if you put in the correct fields for on there. And Araf, good to have you on. Thank you so much. You're always so consistent. No matter what time I go live, I greatly. Oh wait, no, crap, it's not Araf. Shoot, I forgot your pronunciation. I do remember though that I made it wrong. Uh, it's Araf. Maybe go ahead and post it down below. I know. Dang it, I'm so sorry. I apologize. It's been like 4 weeks or 3 weeks since our last live stream where you corrected me. But I have a Araf. I know it's the UH, I believe, but not the Araf. Sorry about that. I kept on always saying wrong. And yes, I do have a Discord server, which I actually literally have not been on in over a year. And that's my apologies. It's one of the reasons why it's just everything is taking so much of my time with the family. And like, I didn't have time to go back onto the Discord server. But I checked the link and it was still working. I was like, you know what? I got to go back on there and see. It was never, the Discord server was never about me. It was always about a place for your people to help out other people. So I never felt that I never wanted the Discord server to rely on me. And that's why I created having moderators and having students just answer, a place where students could post questions and get them answered by fellow students. That's the reason why I created that Discord server. And so if you have questions or if you like to help people with their math and get a better understanding of math, maybe you see that the poll, there's some people that are doing good, some people that are struggling. That Discord server might be a great place for you to go to either improve upon your mathematical skills, talk with people that are smarter than you, and also help out some other students that are having some simple questions from classes that you maybe took. One thing I wanted to, before I get into your guys' questions, having people that you can rely on or talk about in math that have already gone through your math courses is extremely important. I remember when I was going through my, my math courses in college, and there wasn't a lot of students that had taken upper level mathematics courses, right? And at least ones that you were friends with, right? When you're going through calculus and I don't know, there's a big pool of people that you can talk to about it. But once you get into those upper level mathematics courses, I remember having some struggles, with them. And then obviously I went to my professor and I had some friends in class, but it was still kind of difficult. But then I met a guy that I was playing rugby with, and he was maybe 2 years ahead of me, and he was actually like a math major as well. And that was a game changer for me because he was somebody I could rely on. So it's so important to have people that you can ask questions that have already taken the courses you've taken. And those people are on Discord, right? They're on that Discord server. So I would highly recommend, going in and checking it out. And Araf, RF. There we go. RF. I actually got your question. I'm going to respond to it. It's not a great answer, but I do have something I can at least show you what I did, at least when I was a teacher. And it might not be the best way, but I want to let you know I did see your question and I am going to get to it. And I will plan on for each of these live streams coming up on Sunday, I will plan on at least going through. And again, I apologize, guys. I cannot commit to every single Sunday. I am going to try to commit to a time, usually around 12 or 1 o'clock. And if I can do it later, then I will. But, it's just my life is what it is. It's just difficult. So I apologize for that in advance. But if you guys submit the question, I will see it and I will review it. And I might select it either on the live stream or on a video in my studio, which I'm looking at my studio screen right here. Tosico, thank you so much. Hey, awesome. Well, that's so good. UF, just my neighbor, hour and a half away. I'm assuming UF as University of Florida. RF, good to have you on. Thank you so much. Mr. Villager, do you provide, why is that looking so small? Oh, come on. Let's see if I can fix this. No. All right. Do you provide any help with statistics or AP statistics by chance? Just wondering because I'm taking AP stats now. No, sorry. I'm sure there's some other YouTube channels that have great statistics help, but I am not the one. Well, that's awesome. I'm glad to help you. Yeah, I would say my teaching style is rugged. I appreciate that. It's like and actually, I mean, there's some truth in this to your point. Like I have a math degree, but I think a lot of times people just assume that because you're good at math or because you have a math degree, that you fit into the box of what people expect or think about as math teachers. And I would definitely say that I do not fit in the box of a classical like math teacher. I struggled with math growing up. And even sometimes even like teaching things like, or even when I'm learning things, it doesn't come naturally to me. It doesn't come easy or quickly. So I got to take time for it. But I've also think that that's been a benefit to me as a teacher because I can not only resonate with my students, but I can also look at my instruction from different ways and kind of see, all right, now I understand why students are not getting it. Let me see how I can explain it a different way. And that's very difficult. I remember when I first started teaching Algebra 1, and having that like understanding of why the students were struggling with Algebra 1 stuff when I hadn't taught it in like years, it was difficult to remember like where the students were at. So I think that's something very, very important to kind of, to have that ability that empathy to remember, where students are struggling, why they're struggling, and what foundational stuff they have. You are very, very welcome. All right. So I don't have any work on this, but I've been interested in this theorem for a while and never understood it. How much do you, I do not remember it at all. So I'm assuming I go back and look at it. I remember doing work with it. But it's been such a long time. It was probably back in my college days. I don't remember even teaching, stuff from there. Yes, go and do it. I will be hopping back on this week and cleaning up some things for sure. Hey, Ethan Stackward. Hey, Miss McLogan. Guess what? I'm finally doing engineering classes. I love it. It's been such a long journey. Often felt endless with calc, differential equations, linear algebra, physics. I bet. That is so cool. Yeah, I remember I originally looked into the engineering degree like route, and I was like, wow, there's just so much math. Even though I got my math degree, but like, and then you're getting to the engineering more applied stuff, and I was like, whew, that's just a lot. But it also must make me like you feel so good now that you're over that hump and now ready to actually start doing some stuff, with all the knowledge you have. So that's awesome. This is no, I am in Jacksonville, Florida. But UF is only about an hour, I think hour and like 15, hour and 30 from Gainesville. I have to be in your server for 10 minutes to fully access it. Yeah, well, I don't know. Sorry. Hold on to the side. No, I never taught Calc BC. I only taught Calc AB for a couple years. And then I just never, there was another teacher in my school that was the Calc BC teacher. And like, I mean, she was really good at what she did. She'd been teaching it for years. So I just never got the opportunity to teach BC, but that's okay. Um, yeah, I'll explain at least my way of thinking about it. I'm not a way of a trick that you can use. And again, that just could be, um, you know, maybe there's something I'm missing, but I don't recall learning any way to approach those problems for a trick, but I'll at least show you the way that I look at it. I'm actually here. Well, thank you. Thank you very much. This is more of a student question more than a math one. Well, right now during the live stream, that's what I'm doing, the student questions. But if you have a math problem, then go ahead and submit it there. Or how does someone beat procrastination and start doing what they're supposed to be doing? This is a great question. It's like a human question, right? How do you beat procrastination? And typically we are procrastinating on something because the value of doing what we have to do is not as important as doing what we want to be doing. And that could be just, playing on our phone or, hanging out with our friends and whatever else. So I think one thing you can do is you really got to attach a lot of value into the things that you don't want to do. Right. And what I mean by that is give a reasoning of like, why is it that this needs to be done? Why is it important to be able to, do the things that you need to do? And I think when you give reasoning and you kind of have that why behind things, it helps put things in perspective. And I think that can also like help you reason with yourself of like, this is really, really important. These are the goals that I kind of set out from the year. This is what I want to achieve. I need to get this done. Even though I don't want to be doing this right now, I know this is what needs to be done, going through it. I think the other thing that's really important to help with procrastination is having a schedule, having a time period of like, I am going to be doing this during this time period. And then that's it. No ifs, ands, or buts, no excuses. Like you are doing it. And if you don't do it and if something comes up, then you give yourself a punishment. You have to self-inflict a punishment. And I think the more consistent you can be, with that, I think the better you can overcome procrastination. But procrastination is a human thing. I mean, everybody deals with it and everybody has it. And it just comes into being able to manage it on your own personal level. It's gonna vary from person to person, but yeah, it's critically important, no matter in your studies or in your work life, right? It's always going to come up. So you got to be able to see what works best for you. But those are two tips that hopefully you might be able to use. Why do they make it so hard to find the vertex and zeros in a graphing calculator? I don't know why. I have to set boundaries to find specific points. Do you have any tips to make it faster? No, I mean, I don't know. That's how the graphing calculators are programmed, so you got to have that left boundary, the right boundary. So then the calculator knows to be able to compute to find that intersection point between those boundaries. To me, it doesn't seem like it's that hard. I mean, I think you just need a little bit more practice, but I don't know. That's the day and age of how those calculators were performed. To be honest with you, I really don't love using graphing calculators, and I love using Desmos. And even when I left teaching, I remember they even had like a Desmos like app feature that was on like the Florida exam and stuff like that. And I think that's kind of the way to go. Like, you shouldn't have to like get problems wrong because you don't know how to use a TI or a Casio calculator, graphing form. The technology is out there on your phone or, even in an app that can make it so much easier and stuff like that. So I don't know. I don't know the programming of everything from on there, but I think you just, do some practice with it and I get more used to it. But yeah, I can definitely agree with you. It's not the most easiest the way that it should be. And I even prefer just using Desmos when I can. How do you stop making stupid mistakes in math, bro? Well, guess what? I was actually doing a problem today and I made a stupid mistake. And I was like, I couldn't find it. I go back and I'm checking it. I'm like, where did I make this mistake? And literally, my mistake was from one line to the next, I just wrote the wrong number. Like, instead of 22, like I wrote like 12 or something like that. Like, it was such a simple mistake, but I couldn't find it. It took me like 20 minutes to go through it. So, even at my level where I've done math problem after math problem after math problem, mistakes are going to happen, right? So don't get overly hard on yourself. I think some important things that I always try to do is always show my work. There's a lot of times I'm like, oh, I'm just going to do this on my head. And I always, then my other side of my shoulder is like, stop, don't do it, just write it out. Sometimes it takes an extra 5 seconds, right, to write something out. But what's important about that? One, that helps avoid mistakes when you're writing things out. You're not making a mental calculation. And then two, if you do make a mistake, it's so much easier to go back and find that mistake, right? You can go line by line and mentally be checking your work as you're going through it, right? And that's how I found my mistake. I was like, this is not the answer I need to get. Where did I go wrong? So I went back to my work and I deliberately wrote down each and every step of my work, because again, that's how I know my brain is trained. Like, that's how I avoid my mistakes. And I was able to find the error. And again, it was a hard error to find because I literally I'm like, how did I get this number? Where did that come from? I'm like, I literally just copied a number wrong. So go slow, write down your work. Uh, well, yes, go slow, write out your work. And then, yeah, be able to, check your answer. I think is always helpful for you. But also just remember, like, don't be hard on yourself, guys. It's, they're going to happen. Somebody has not been on my stream for very long. No, the short answer is no. I've not always been good at math. I struggled with math, and actually, you remind me I should probably make another updated video on my story, because I struggled with math when I was growing up. I was not a and B student. I think I only had like a B once. I was mostly a C and D student. I didn't do well. I did get D's in college or in high school, specifically my pre-calculus class, because I just faked my way through math. I just did what I needed to do to get the grade. And I didn't care about understanding it. I didn't care about actually learning it. I just wanted to get to the next class, right? And I just wanted to do good enough to get a good grade. And then I made the decision that I wanted to become a math teacher because I wanted to coach sports and I liked math out of all the subjects that I could have taught at the high school level. And I got a rude awakening that I really didn't know anything about my math. Like, I knew little things, but I really had no good foundational knowledge of mathematics. So I had a big task on my hand when I went to college, and I went through a lot of struggles, a lot of pain. I had to do a ton of work, but I sucked it up. I took responsibility. I did all of the work, and I graduated with my math degree. And I'll say that's probably one of, my top 5 proudest moments of my life. Not because not so much of just earning the degree, but of the struggle that I had to go through and the work that I put in to get that degree. And so I was very proud, of myself. And that's why I'm a big proponent of students that feel like they struggle in math, that they cannot be successful. And no, I don't think the pinnacle of your life needs to be able to get a math degree or get an A in mathematics. But I think when you give yourself time and you put in enough work, that there is nothing that can prevent you from learning the material that you need to learn. And that's why I'm just a big proponent of being able to help there and be there for people, to keep on encouraging them and motivating them to put in the work, ask questions, and do the best that they can do. And they'll start to see gains. It's not like I learned how to do math better like overnight. It was a long struggle. And I realized not everybody in their life needs to go through the struggle that I went through. But I also feel like a lot of people avoid math and avoid the struggle just because it's a struggle. And I don't want people to make that decision just on there. I think it's a very helpful and healthy to go through struggles in your life and to work through them. And because some of the best feelings that you're going to get on your life is working through those struggles and looking back and seeing where you are now to where you were. So I wasn't really inspired. I just had a lot of really good mentors. All the coaches all the coaches I had, my baseball coach, my football coach, my wrestling coach, not all of them, but majority of them were teachers, and 2 of them were my math teachers. So I will say that kind of inspired me in that regard. They were just mentors of me, and I really looked up to them. And also my mom was a math teacher. So I was just kind of surrounded by people that worked in the educational business. And I just loved that. And I just kind of felt like that was the natural gift that I kind of had. I really liked working with people and helping people. And I had an interest in mathematics, but I just wasn't that good at it, growing up. So it was just kind of one of those that, yeah, I just felt like it was the best path for me and the most natural for me. And that's where I went. I had a question in my pre-calc course. Is there an easy way to memorize secant, cosecant, or cotangent graphs and their features? Yeah, there is. Basically, memorize sine, cosine, and tangent, and just understand how there are the reciprocal of those graphs. So I think if you can have your sine, cosine, and tangent memorized, which I have a video on, I have it in the docket to be made. So it's probably not going to be made anytime that you would be interested in the video, not like soon enough for you. But I think the most important thing is knowing your sine, cosine, tangent, and knowing the invert, and then just knowing those graphs are the inverses of them, and their intercepts, are the vertical asymptotes. The maximum is the minimum, vice versa. That will help you kind of do a quick sketch of the graphs and understand the elements from there. Any tips on pacing yourself on math exams? That's a great question. I don't think I've ever been asked that question. Pacing yourself on math exams. I think being a little bit of a math nerd, I would look at how many questions I need to answer, and then take the amount of time I have, divide the amount of time I have by the number of answers. I kind of get an idea, like, do I have 2 minutes, 3 minutes, 5 minutes, right? And that would just kind of be on my mental clock. I don't want to spend more than that time on an allotted question at the beginning. That's why I always tell students, do the easy problems first, then work on the problems that are a little bit more difficult, maybe take a little bit more time, do those next, and then wait till the end to do those problems that are the most difficult for you. Then that can, if you are going to be spending like extra time on your test, then at least you're spending your time, with the problems that are most difficult, that take the most amount of time. And hopefully, if you already did the problems that you know how to do, you'll have more of that extra time to be able to do that. Hi there, I've tried to find videos on half angle, sum, difference, and fundamental trigonometric formula. What is the best way to approach this in pre-calculus? If you go to my playlist and just type in and go to like on my main channel, go to pre-calculus, I have a ton of videos on half formula, sum and difference, and double angles. So, I would just, as far as like a resource, that's what I would recommend for you. But yeah, I think it's a natural progression from solving equations and then understanding the double angle, half angle. There's a lot of videos, a lot of content that I have on from there. So I would just maybe start with some parts that you're kind of confused on, and then, build it from there. But you can always go to brianmclogan.com/Q&A, submit a math question, and I'll be more than happy to do it on a live stream like this. I prefer using the reference angle or a reference triangle as far as part of using the unit circle. So I believe your question, and I'm not sure exactly how you use a reference triangle, because I'm not familiar with that, but I'm familiar with using a reference angle, so I can kind of see how a reference triangle would make sense. But yeah, I recommend to my students, and the way I do it is understanding the first quadrant of the unit circle, and then basically using that reference triangle to be able to find any other points. Go ahead and submit it to brianmclogan.com/Q&A. Yeah, that just sounds like good. Um, that just sounds like good university stuff. You know, it's part of the life, man. I love it. Why are these stupid proofs important in geometry? Well, I love proofs. I hated proofs in geometry, but once I got to learning how to write proofs in my upper level classes, I love this stuff. And so it got to me thinking, I'm like, why is it I hate this? Why is it I hated this stuff in high school? And I love the stuff writing, in for my college courses. So, you know, um, I think there's an importance of being able to articulate and make an argument using proofs. And I think that's one of the important things about having students being able to construct a proofs in mathematics. I think though sometimes in the high school geometry class, they can sometimes do more harm than good because students a lot of times they don't have the fundamentals. Like when I took proofs in college, like we went to the basics. It was almost like nobody took proofs ever before. Like we went through the basics and we just really focused on all we did was write proofs. And actually that was like my writing class for college. Like that's how I got my credit for I only had to take one English class. Like that was because all we did was write proofs. That to me, that was much more beneficial than the makeshift proofs we would do in geometry. And not to say that the proofs in geometry, again, are like a waste of time. There is importance of being able to, you know, as I mentioned, like construct those arguments to be able to show something, having those given statements and being able to construct something from there. I just I don't think we go deep enough in the high school class on proof making for students to get a true benefit of it. I think we just kind of touch the surface on it, and students are like, this stuff stinks. Like it's just hard to understand, why are we doing this? And I think that if I was probably to encapsulate high school education as a whole, it'd be like that. We tackle a lot of topics on surface level and we don't go deep into them. And so then students really never have a true understanding of what they're doing, why they're doing, and how it relates to so many things, because we're always concerned about touching on so many different topics to be able to have presented for the final, exam or the state exam or the ACT, SAT, college entrance exam, blah, blah, blah. And so students like myself have gone through high school, like learning a little bit of everything, but only getting that surface level knowledge of it. I got a B in college pre-algebra. Now I'm in trig, the class before calculus. Do you have any advice to help with an anxiousness? I see problems calc has, and it looks intense. Yeah, don't look at them. like, um, don't worry about it. You're gonna get there. And I remember looking at problems, and I can relate to you. Okay, that's why I'm laughing. I can relate to those feelings. I can relate to looking at things and being like, "Holy crap, I'm gonna learn this." Like, this looks so much more difficult and everything else. And of course, if you don't have the knowledge that you need to be able to solve those problems, it's going to look confusing. You're going to be anxious about, how am I ever going to learn this stuff? But the one thing that I can tell you, I remember taking calculus the first time. And I remember after I took it, I was like, wow, that wasn't that bad. Right? Because calculus is always kind of like referred, talked about as like, oh, that's such a tough class, or students that know calculus are really, really smart, right? And like, it's just kind of put on a pedestal as like this, if you made it to calculus, like you are a certain type of student or whatever. Either you're smart or you're really studious and whatever may be the case. And I remember taking calculus, I was like, that wasn't that bad at all. And, you know, I was like, I, I had the foundational knowledge that I needed. And to be honest with you, that's why most students struggle in calculus, is they don't have the foundational knowledge. So once you have that foundational knowledge and you go through the calculus, you're like, yeah, some of the notation looks confusing, some of the problems look confusing, but a lot of the straightforward process that you're doing is nothing crazy, right? It wasn't until I got to the upper level mathematics courses where for those, um, I underprepare. I was like, oh, this sounds like an easy course. Like, this isn't going to be so bad. Like, I already took calculus. I already took linear algebra. I can handle this. And then I realized that, holy crap, I don't know anything about mathematics because those are some very, very difficult courses. Um, but, like, it's just funny. It's like you're going to get anxious. The anxious is coming from what you don't know, right? So just tell yourself that until you are at the point where you have been provided what you need to know and then you're going through it, like, don't, it's easy to say, I understand that, but don't let that eat you away. Hey, I got a pre-calc quiz tomorrow, verifying trig identities. I love verifying trig identities. What is the final tips do you have about that? Also, I plan on taking AP Calc AB next year. Can you give me some advice on that? Yeah, just make sure that you're doing all the work. Maybe even do more work than you need to. Calc AB, Calc ABBC, it moves fast. So you got to make sure you're staying on top of your game. And I think that was one of the hardest thing that a lot of times students had, that when I taught Calc AB, they might slack off, and then they maybe weren't doing their homework, or they maybe would take a break off, and then before you know it, they're now behind and they're struggling. So really, really stay on top of those courses. Make sure you're doing as much of the work, and sometimes you might even need to be able to do more if you really want to go for that 5 on the paper. As far as trig identities, it's I have videos on tips for trig identities. I think converting things to sines and cosines is very, very helpful. I think you're looking for those algebraic relationships that you can apply. And, it just comes through doing a lot of practice problems. So unfortunately, I have an idea for making a math video on trig identities, which actually I just wrote out. It's not going to be in time though for you. So I apologize for that, but I do have some videos on, some tips if you want to maybe, check those out before you go, and just do the best you can get. Just do the best you can. And, you're going to do fine. I got to be in college algebra. Now I'm in trig. Oh, wait. Yeah, I just talked about that one. This is an interesting question. Would you go back and become a professor? Well, I don't think, I'd have to think, get my master's in math, which I would love to do, but time wise at this point, I don't think even going back to school, like advancing my education, is something that would be on the table. My kids are young. They take up a lot of time. They deserve a lot of my time. So I don't see myself going back to school and advancing my education that way. And the same thing, even teaching classes, like I miss teaching inside the classroom. I really, really do. And then, but I also think about the time that it involves, with teaching. And I just don't see, I don't see an avenue where that would work right now in my life. Maybe later down on the road, my kids are like grown up, and maybe if I'm still making YouTube videos, that'd be cool. I could be like the longest tenured math teacher on YouTube. Um, and then I go back into the classroom and see what it's like. I don't know. We'll see what the future holds. But right now, my life is just so busy with my young kids. And I just couldn't see myself going back into a classroom at the moment. I just want to say thank you so much. I was so confused for math and I started recently watching your videos and finally understand math and made it feel huge. Really well, awesome. So happy to be helped you out. I really, really do appreciate you letting me know and jumping on the stream. I don't remember. There's a lot of websites and a lot of people that like truly nerd out over the AP exam. So if you do some research, you'll find a lot of good research stuff. I haven't looked at AP exam stuff in a couple of years, but last time I was even checking, I was like blown away by how many resources there are online for free. And I even know the College Board has a ton of stuff as well. But yeah, man, just take a look online. There's some amazing teachers that have put together a lot of information for you to get you ready and prepared. Even if you don't have a great AP calculus teacher, there's so many great resources online for free that if you're willing to put in the work, you can be successful. Do you have any tips to do well in trigonometry and algebra 2? I hate teaching trigonometry and algebra 2. I just wish it could sustain pre-calculus or in trigonometry. So I don't have any tips because I don't love that it's taught in that course. I would just understand the basics. Make sure you understand your sine, cosine, and tangent. And whatever your teacher, however deep you guys are going to go in with it, But I think as long as you have a good solid foundation with that, I think even sometimes they teach you the unit circle, just, um, just do what needs to get done. And, don't worry because it's going to be drilled into you next year in pre-calculus, and that's the important thing that I think is the most important. Like, it's not important for algebra 2. It's taught in algebra 2 as, it's like they just want to cover surface level stuff so people are prepared. But I'm like, as a pre-calculus teacher, I was like, don't teach them that. It's okay. I'm going to go through it from the basics with all of my students. I'm going to, even if they learn it before, I don't care. I want to make sure they learn it my way and understand it from my way. So I didn't care that they taught it, from there. So hopefully you'll have a pre-calculus teacher that's going to go through it, not assume you know stuff from algebra 2. Because algebra 2, let it be algebra 2. Keep trigging pre-calcs. I want to get there. I do have my calculus channel going already. I'm getting into my rhythm routine. So unfortunately, RF, I'm not going to be able to get to BC topics for this year for you, but that is a goal of mine, as I think I've stated multiple times. No, but I mean, same thing. I mean, I have some videos on it where I go much in depth. I think just make sure you're applying your algebraic, properties, and then converting things to sines and cosines are two of the most important tips that I can, help you rely on, knowing your identities as well. You are very welcome. What do you think about Khan Academy for learning AP Calculus? Because I'm struggling in my class currently, and I have an A in my pre-calculus class. I haven't looked at the AP on Khan Academy stuff. I remember when I was teaching it, I used it for some stuff. I didn't love it for everything. So, I don't know about that as like a total guide. I will say one teacher that I did love when I was learning it. I am gonna forget his name. Crap. Let me see if I can find Corby. That was it. I remember when I was like teaching it. Yeah, Corby's World. I'm actually gonna give this dude a shout out. He had some awesome stuff. Has anybody that's in calculus learned from this guy? I think he's an amazing teacher. I'll post the link here and there. I think he's done an amazing teacher. And like when I was teaching AP calculus, sometimes I would because it was like my first year teaching it, and I had a master teacher next to me, but she was busy. She couldn't explain everything to me. And like, I knew how to do things, but I also wanted to teach things in the AP kind of realm, right? For students to kind of like understand it from there. And I remember I stumbled along his website, and I just always thought like his instruction was very, very good from on there. So I'd maybe check that out for on there. I just posted it inside the chat. All right, guys, I think is AP hard without much trig knowledge? My dual enrollment pre-calc and calculus doesn't have trig, but I'm considering AP Calc AB next year. I mean, I think you're going to want to do some brushwork on the AP on your trig. That could definitely hold you behind. So I would recommend doing some trig work ahead of that for sure. I think that could set you back a little bit. I don't think it's a huge thing, but it could definitely impact you if there's. Hey, Eddie. What's up, McLogan? Do you ever zone out in class when you were in 10th grade? Yes, all the time. Actually, I didn't zone out. Well, I did zone out, but more often than not, what I always did was I just doodled on a piece of paper. Like I would listen and I would just draw pictures like in class. That's all I did. I would sometimes take notes, but like I'd mostly just like listen and like draw stuff from on there. So I wasn't the great student. What is it about math that interests you so much? I ask because maybe your answer would change my view on math. Well, I don't think I can give you an answer that would change your view on math, because if I can always, I'm just assuming at this point that you have a tainted view of mathematics. And I was actually talking with somebody earlier today about this, and they talked about how they didn't like math and like they didn't understand how I enjoyed math as a math teacher. And I'm like, I agree with you. I think that you've had a disservice. If you hate mathematics, you have a disservice to the education world has given you a disservice in teaching you math. I don't blame you. I can't like undo that. But and I went through that as well. Like I didn't, even though I like enjoyed math, like I didn't love math. Right. And so I guess, I guess what I love most about mathematics is one, once I got to enough mathematics, like above calculus, I was able to see everything coming together. And once you kind of get to that, where like everything now kind of makes sense, why you were doing all of this stuff, then you're like, oh, and then you see it all in the world and how it's in all this applied physics and engineering stuff. You're like, now I get it. Like, holy crap, it isn't everywhere. Like, everybody needs to see this. Like, this is amazing. I love this stuff. So, but until you like get to that point or sharing it, like, it's hard to really always describe it. You know, you always hear people say math is all over, all around us, and it's the foundation of everything. But I think until you have reached a certain point, it's really hard to kind of understand that. And but I also think that our education system has just done a disservice of teaching people mathematics. Like I said, we teach this mindset of to a test, and we're never going to admit we're teaching it to a test. But like we teach so many topics on a year, you know, and it's not about really truly understanding everything. It's just about learning enough so you can get through the information. So therefore you can take the end of the year test. So therefore we can get some data and know if you guys are improving, declining, blah, 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 blah. What is, you know, we can assure that you have learned something. And that system is not built for, you know, students to get a true understanding of mathematics. That system is built for us to be able to monitor our student progression. And I don't have a problem against monitoring student progression and testing and stuff like that. I just think the system that we've built up and the way that we approach learning mathematics has built a society of people that hate math. And so I can't blame you on that. I just hope that, you know, that you give maybe math another chance and take it at your own rate, take it at your own time. And maybe you might see some enjoyment in it and maybe not. But I can tell you that I've received a lot of messages from people that were parents, or maybe that were retired and they're going back and learning math at an older age. And they have so much more of a foundation of, you know, in life experiences that they can relate and understand things. And it makes all the world of sense to them now. And they're like, I can't believe I struggled with this, you know, or I didn't like this stuff. This is fun. This is enjoyable. So don't feel bad if math is not your thing now, or it's something that never makes sense to you. Like, give yourself time and, you know, maybe find some things that you can, you know, try it. And once you start, I think seeing some connections or seeing some enjoyment, that might change your perspective on there. But I don't think there's anything I can say to you that would necessarily change that perspective. Best of luck. You got this. RF, you're taking BC. He has a lot of good stuff on BC. I would definitely check him out. Check him out. Next live stream. Let me know what you think. I mean, obviously every teacher is not for everybody, right? He's a very goofy kind of teacher or whatever else. And like all of his stuff is like screen recorded. So, you know, it might not be the best fit for you, but I think his explanations are pretty good. And yeah, he was actually more of a BC teacher than an AB. But yeah, I think for as far as preparing you for the calc exam, he might be a good resource for you. I don't know. I haven't seen any of his stuff on geometry. I know he touched a lot of like algebra and calculus and pre-calculus, but I'm not sure on geometry. But I don't know. Check out his channel. I haven't looked for it or seen anything on his. All right. Explanation on problems. Well, you can submit to brianmclogan.com/Q&A, or I don't know, maybe like use an app that has like explanations for it. You know, there's a lot of apps now that you can type the problem in and it'll explain to you step by step how to do it, right? So just type in your problem on Google and you'll see all these apps that will populate up, you know? I mean, to get those explanations, more likely than not, you're gonna have to pay. But if you want something that's consistent and that's gonna work for you, then, you know, I'd maybe check that out. All right. Now it is time to get into some math. Woohoo. No, let's move that over. Cool. All right, guys. So I'm going to do something a little bit different. I now have, I can put this over here. Let me put it like this. There you go. So what I have now done is I've taken some of the questions that have been submitted to me. This one is, first one is for Vince. And so now I'm just going to go through the questions. So I think I selected like 5 or 6. I'll go through them. And again, if you have a math question, go to brianmclogan.com/Q&A. Submit your question, take a photo of it, insert the PDF. Just give me some specifics of what you want. I write down what you guys submit, so therefore I can remember what that problem or what your question was about, and then we're going to go over it. So if you do have any other math questions, go there. If you have a general question, I'll try to revamp back over onto this live chat. But, you know, it's always kind of difficult when, as I'm teaching. So I have your chat up there so I can see your chat in that regard. But I'm not probably going to be able to answer majority, like a depth of question as I'm doing the math. But I'll try to maybe wrap up here at the end, see if there's any other good questions I can respond for you guys. But any math, don't even bother typing it in there. You got to go to brianmclogan.com/Q&A. All right. So my boy Vince says, in the screenshot I sent, I don't understand how you used another x on both sides and how below that resulted in a negative 1x plus 4. Can you explain the whole concept around canceling out numbers? Well, yeah, canceling out numbers is not really a good way to describe what I was doing in this problem. This is actually a screenshot of a video I was making. So let's just take an equation. So if I had 5 equal to 5, right? We know that equation, that works. Now, what I could do here is I could subtract a 5 on both sides. Let's not do subtract 5. Let's subtract a 1 on both sides, right? So I have 5 minus 1 and minus 1. So technically, we write that as 5 minus 1 is equal to a 5 minus 1. Now again, as long as I'm doing the same operation to the left side to the right side, that is our property of equality, then I'm still going to have an equation that is going to be true. So 4 is going to equal to 4. Now, there's a couple things that we need to understand. So that's why that's why I'm doing things on both sides of the equation. I think it's also important to recognize in this case that we understand, like if I have 5 minus 5, that is equal to a 0, right? That is what we call our additive inverses of each other. And in the same thing, if I did 5 divided by 5, that would equal to a 1, right? That's the multiplicative inverse. So 5 minus 5 is going to equal to a 0. Now, if I had a 5x minus a 5x, then again, that's going to equal to a 0x, right? Which is just also equal to a 0, because 0 times anything is 0. So let's go and look at the problem that I had. I had an x plus y is less than 4. Now in this problem, what I need to do is I need to isolate the y. Oh, that was the one last thing I wanted to do. So if I had an x plus 5 equals, 9, right? So if I want to solve for x, that means I need to undo what's happening to the x. So if you read this equation, it says x plus 5, how do you undo adding 5? Well, you're going to use the inverse operation, which is to subtract a 5 on both sides. So x is going to equal to a, sorry, I was actually going over what I didn't want to do for you. So now, if I subtract a 5 on both sides, we write it like this, but technically what it's doing is x plus 5 minus 5 equals a 9 minus 5, right? You could also write it like that. This just saves some room here. So what is 5 minus 5? Well, that's x plus 0 is equal to a 9 minus 5, which is 4. Well, what is x plus 0? X. So x equals 4. So we say like subtract 5 on both sides, cancel out, but they're not really canceling out. They're just subtracting to 0, and x plus 0 is equal to x. So in the problem that I was talking about, the same thing here. Now in this case, we're trying to undo what's happening to the y, right? Now this one is not x plus 5. This is x plus y, but we want to solve for the y. Well, just remember, guys, multiplication is cumulative. So if I have x plus y, I can rewrite that as y plus x, right? So you can look at it this way if this makes more sense to you. So again, like if you need to get rid of the x, what do you need to do? You need to subtract the x. Okay, so again, I have a y plus x minus x is less than a 4 minus x. Thank you, MacJello, for the super chat. I very, very much appreciate that. Thank you so much. So in this case, I have a yx minus x. Well, again, just like it over here, like 5x minus 5x is going to be 0x. So x minus x is going to be a 0x, which is just going to equal a 0. So that's how I get the y plus 0 is just y. So less than a 4 minus x. And what did I do here? Oh, okay. And then what I did over here was typically I was going to rewrite the variables in front. So therefore you can just rewrite it like this, plus 4, right? Because that's a positive 4. So you can just rewrite it like that. I was teaching, so I might have skipped some steps for my students. That's why it might have been a little bit more confusing, but hopefully for this video, that helped you out from on there. All right, Twitch, Dumukori27. Please sub to me on Twitch. I'm not on Twitch. I'm not going to go on Twitch. Sorry. Please, I like your videos and sub to you. Just please. Sorry, I have no reason to be on Twitch. All right, his question, but thank you for submitting your question. So he has 6x plus 9 is greater than 57. Which of the following graphs shows the solution? All right, so let's just work it out, guys. So we have a 6x plus 9 is greater than 57. All right, so first thing we're going to do is use the properties of equality. So we're going to undo, isolate the x. So we're going to subtract a 9 on both sides using reverse order of operations. So 6x is greater than a 48. Divide by 6, divide by 6. X is going to be greater than 48 divided by 6 is going to be 8. So x is greater than 8. So which of these graphs, which of these graphs represents values that are larger than 8? Well, not this one and not that one. And you can see this one is only for values that are greater than 11. This one's greater than 8. So ding, ding, ding. That is going to be my answer. Now, Supreme Dope 02, YouTube, please sub to me. Please sub to me. YouTube, please. I started. I think this might be the same person because the problems they submitted look very, very much the same. Has to solve an inequality and graph the solution on the number line. Which of the following inequalities did she solve? Now, we know the solution is x is less than or equal to 5. So there's a couple of different ways you could do. You could go ahead and solve each one of these equations and see which one is going to be less than or equal to, or less than or equal to 5. Or you could plug in a 5 into each one of these and see which one of those is going to satisfy the inequality. I would assume that since we already know the answer, probably plugging them in is probably going to be the fastest way. So let's just try it that way. So here I do 3/7 times 5 plus a 1/7, and then it's less than or equal to, now here I'm going to convert this to a improper fraction, so that would be a 13/7. Well, that's going to be 15 plus 1 is 16/7, so 16/7 is not less than 13/7, so it's not that one. This one's going to be 1/5 times 5 minus a 3/5 is less than 2/5. So this is going to be, or less than or equal to. So 5 divided by 5, those are going to divide out, right? So it'd be 1 minus a 3/5 is less than or equal to a 2/5. Well, you could rewrite 1 as a 5/5, right? 5 divided by 5 is the same thing as 1. So if I have 5/5 minus a 3/2, that'd be a 2/5 is less than or equal to a 2/5. Seems like B is going to be my correct answer. Now, if we're maybe just concerned, or maybe we're like, well, let's just double check, make sure we didn't do any mistakes, Mr. McLogan. I don't know. Let's just go and double check the other ones. So 3/5 times 5 didn't really take that long, right? Plus a 2/5 has to be greater than or equal to. That'd be 3 times 5, right? You take your denominator, multiply it by your whole number, add your numerator. So 5 times 3 is 15, plus 2 is 17. So that's a 17 over 5. Now, you could cancel those out, right? And in this case, I want to know, is this larger than 17 over 5 or not? So that's going to be 18. I'm getting a 20 over 5. Am I making a mistake? Because that one sounds good. Because that goes in there 4 times. Yeah, that works. I don't know. Let's check out the next one. Which of the following quiz did she solve? Oh, well, I don't know. Yeah, you got to see, well, which one is going to equal to that 5 half. So I guess I do need to work them out. Yeah, because it could be 5 or not. Well, okay. The answer is B. This one satisfies it, but it's not going to be greater than or it's not going to be 5 greater than or equal to. Let me just solve this and verify that. So 1/5 x minus a 3/5 is less than or equal to a 2/5. All right, so what I'm going to do is add a 3/5 to both sides. So I have a 1/5 x is less than or equal to a 1, and then x is less than or equal to 5. And there you go. Ding, ding, ding. So that's your answer. I guess solving it, each one is going to work because that's what we need to get. We need to get to x less than or equal to 5, not just satisfy that they are true. So my apologies. That was the wrong way to approach the problem from the beginning. Just should have gone through and solved them because this is what we need. Me and Shelby trying to get 100%. So weird. It's all these inequality problems. So I don't know what's going on here with you guys. I guess inequalities and maybe trigonometric identities is like the big thing. All right. So I have a video. I will make that next. I'll make it tomorrow. I promise, on trigonometric identities. It's just probably not going to be ready for those of you guys if you have tests and stuff like that, but I will make it. All right. Trying to get 100%. Solve 1/4 x minus 3/4 greater than 5 and 1/4. So the first thing I'm going to do in this problem is I'm going to convert this to an improper fraction. So that's going to be 21 over 4. Now, since everything is divided by 4, I can just rewrite this as an x minus 3. I can just multiply everything by 3 now. I'm sorry, everything by 4. And I'd get a x minus a 3 is greater than 21. Then add a 3 to both sides. X minus 3, x is going to be greater than 24, which is that answer. All right. Frank-12-I2W. I'm having trouble understanding how to solve this kind of equation. And when I do get it, after my teacher teaches for about 2 hours, I forget how to do the entire thing when she gives me a whole new problem. I also can't seem to find any videos on YouTube to help me understand this. Is it okay if you give me some practice problems and example problems after you teach it? No, sorry, I can't do any of that. But thank you for reading this and hope you have a nice day. Well, I am having a nice day, and thank you for being that. I don't like your X's just because I didn't initially recognize them to be X's, so I'm going to go and fix that. But it says solving elimination and substitution. Immediately when I look at this problem, I think about solving this via elimination. So the answer is going to be the exact same. It might be a little bit more messy in a substitution or an elimination. I'm not really sure, but you're going to get the exact same answer. But I am going to work through solving this through elimination. And if I was going to do elimination, the first thing I would want to do is get rid of this radicals. All right. So when I want to do elimination, I want the same coefficient for my variable x to be the exact same, one positive, one negative. So now I got to think of, well, what do I need to multiply this square root of 7 divided by 2 to be the exact same thing as square root of 7 divided by 4? And you recognize I just need this 2 to be a 4. So what I'm going to want to do is multiply by 1/2. Okay. So, but I also want it to be negative. So what I'm going to do is I'm going to multiply your top equation by a negative 1/2. You got to make sure you multiply it by everything. So when I go ahead and do that, I'm now going to get a negative square root of 7 over 4. And then let's see, negative 1 times 2. So that's going to be our x. And that's going to be a minus a 2 over 6. What am I doing? Let's write it like this. Minus a 2 over 6y. And that's going to be equal to a positive 3/2, right? Because negative times negative is going to be positive. My bottom equation is going to remain exactly the same, so I'm not going to do anything there. I'm just going to rewrite it. 5y equals a negative 7. Okay, so now you can see my coefficients are exactly the same. One's negative, one's positive. So now I can just go ahead and add. So I go ahead and add. Those are going to go to 0x, which is just 0. Then over here, I basically have a, let's see, that can reduce down to a 1/3. 1/3 y minus 5. So how are we going to do that? So we have a negative 1/3 minus a 5. Well, again, remember, guys, you can rewrite this 5 as 5 over 1 and then multiply it by a 3 over 3, right? So technically, it's a negative 1/3 minus a 15 over 3, which is equal to a negative 16 over 3. So I have a negative 16 over 3y. And then some more fractions, okay? And then, so now I have a 3/2 plus a negative 7. So again, I'm going to convert that 7 to a 7 over 1, multiply it by 2 over a 2. And so now let's see what I'm going to get here. So that's going to be a negative 14. So this is a negative 11 over 2. So my negative 16/3 times y is going to equal to a negative 11/2. Okay, now to solve for y, all I simply need to do then is to multiply by the reciprocal, right? If you want to get rid of a fraction, you want to get it to 1, just multiply the fraction by your reciprocal. So I will multiply this by a 3 over negative 16, and a 3 over negative 16 on both sides. That's going to now give me y equals, and then over here, this is going to be a negative 33 over a negative 32. So y is equal to a 33 over 32. Could have just done that the first time. Okay, so we got 1, right? Now again, remember, solving a system equation, we need the y and we need the x, right? Okay, so we got y and x. Y equals 33 over 32. Now what we got to do is got to plug it in. So which equation do we want to plug it into? I'm going to plug it into this top equation because the top equation, you can see, guys, already has a fraction, right? So let's go ahead and plug it into there. Okay. So y equals 33 over a 32. 33 over 32. So let's go and plug it in. So I'm going to have let's draw a line here. So I have a square root of 7 over 2 x plus a 2/3. Now I'm going to insert in this 33 over 32. That's what my y is equal to, right? Rather than using y, I'm using this value. And then that is going to equal a negative, that equals a negative 3. Okay, so now let's just solve for x. So I have a square root of 7 over 2x. This is going to be plus a 66 over 3. So that's going to be 30, 60. Oh, wait. What am I doing? These can reduce, right? 3 over 33, that can reduce to an 11. 2 over 32, that can be 1 over 16. So this reduces to an 11 over 16 is equal to negative 3. Now let's subtract 11 over 16 on both sides. So I have the square root of 7 divided by 2 is equal to, I got more of this math. So we got a negative 3 minus an 11 over 16. Again, rewrite your 3, ladies and gentlemen, over 1, and then multiply it by 16 over 16 on the top and 16 on the bottom. So that's going to be a 16, 32, 48. So that's a negative 48 minus an 11 over 16, right? That's kind of a box from on there. All right, so that's going to be a negative 59. Wow. So this still has an x there. Okay, so square root of 7 divided by 2. Square root of 7 divided by 2x is equal to a negative 59 divided by 16. And then again, to solve for x, I'm going to multiply by 2. Yeah. So then I'm going to multiply by the reciprocal. So x is equal to a negative 59 divided by 16 times the reciprocal of this fraction, right? Which is 2 over the square root of 17. That is going to divide by to 1 over 8 and then rationalize the denominator. You get a final answer of negative 59 square root of 7. Why did I write 17? This is where those stupid mistakes start to come in. Negative 59 square root of 7 divided by 7. Whew, wow, there you go. That is your x and your y solution. All right, last one. I think this is the last one for the night. Yes, this is the last one for the night. Okay, how would you find a simplified solution if there are multiple angles like 3x in the trig function arguments of your equation? I have an example attached where there are 3 different solution sets, but when you actually start writing out individual solutions, I noticed that really the more simplified solution set out would be x equals pi over 6 plus 2 pi n. So is there a way to know that this is a simplified solution set without having to annoyingly write out all the individual solutions and trying to find a pattern between them? I don't know. I don't know if there's a tip or a advanced way to be able to do this. I'll work through this problem and just kind of show you the way that I taught it and the way I've done it. And if anybody wants to comment down below of a better way, then let me know how to do it. So the way that I approach this problem is, well, so first of all, we forget about the triple angles. I don't care about the triple angles, right? And for a lot of students that even struggle with math, sometimes I would even say, you know what? Even if you don't like the trig, like let's just break this down into a 2x squared minus x minus 1, right? That is the factored form in terms of that without the signs going on, right? So forget about the triple angles, forget about the trig. If you were to rewrite this in terms of x's, this is what it looked like. Now, can we factor this? Now, hopefully you recognize this is not a hard factoring problem, right? If you were to break this down in terms of factored form, it would be a 2x here and have to be an x. Now, there's only 2 numbers that multiply to give you negative 1, right? Negative 1 and positive 1. So which one goes which? Well, I know that since my middle term is negative, I want my 2x to be multiplied by the negative 1. And then, so therefore, this one has to be a positive 1. And again, let's just double check. 2x times x is 2x squared. Good. 1 times negative 1 is negative 1. Good. And does your inner and your outer add to give you negative x? Well, 2 times negative 1 is negative 2x. 1 times x is x. Negative 2x plus 1x is going to be a negative x. Voila, we're good, right? Okay. So we got that. That's going to be the factored form. And the reason why that's important is because the first thing you got to do is factor this out. And again, don't worry about the triple angles for right now. Still, you can just factor things out. Like, remember, this is your x. If you want to use substitution, you can. Like, let u or x represent 3 theta to help you. A great technique you can use. But this factored form is going to be a 2 sine of 3 theta minus plus 1 times a sine of 3 theta minus 1 is equal to 0, right? So again, once you know that you have a product equal to 0, you can apply the 0 product property. So I have a 2 sine of 3 theta plus 1 equals 0, and I have a sine of geez. And I have a sine of 3 theta minus 1 equals 0. So now use your inverse operations to isolate the trig function. So I'll subtract 1 divided by 2. So I have a sine of 3 theta equals to a negative 1/2. And over here, I have a sine of 3 theta, not 30, it's 3 theta. Sine of 3 theta is equal to a positive 1. Okay, now to get to the theta though, I need to undo the sign. And to undo the sign, I got to find the values of sine that coincide with the negative 1/2 and the positive 1. So I'm going to go to my handy dandy unit circle. And yes, I have my unit circle memorized decently. So I'm going to spit out these values rather quickly, not spend too much time. Expect that if you're doing these types of problems that you have a general idea of the unit circle. Okay, so when sine is equal to 1, that's going to be this point right here, which is going to be a pi halves. All right, now again, we're trying to, whenever we're dealing with triple angles or half angles or anything else, you want to find all the solutions, okay? So you don't worry about the restrictions of, you don't worry about your triple angle until the very, very end. So 3 theta is equal to a pi halves. Now, if I want to find all the solutions, how do I keep on getting the solution? I got to keep on going around and around and around, right? Which is going to be adding a 2 pi n. So you have to add 2 pi, or you could subtract 2 pi. That's why n represents any integer. So it's going to be plus a 2 pi n, where n represents any integer. Okay, then to solve for theta, now you can divide by 3 on both sides. So I'll divide by 3 on both sides. And then now I get my final answer of theta equals a pi over 6 plus a 2 pi n over 3. Whew, okay. So what about the next one? So this one says sine of 3 theta equals a negative 1/2. And so obviously when sine equals negative 1/2, we know it's in the third and the fourth quadrant. So that's going to be this point here and that point here. What exactly are these two angles? Well, I know halfway around a circle is pi, right? And I know sine is 1/2 at the pi over 6, which is the reference angle. So this is going to be pi over 6 over pi. So that'd be 7 pi over 6, right? So I can do 1 is going to be 3 theta equals a 7 pi over 6. And then now again, the problem is though, and actually if you look at this, 1/2, 7 pi over 6 thing, yeah. So 7 pi over 6. Now, immediately though, when I'm looking at this, I already wrote these two answers. Yeah, here and here. 7 pi over 6. I'm already starting to see the symmetry. Do you guys kind of see the symmetry between these? Doesn't it look like there's an even amount? Well, let's just finish this anyways. To get all the solutions, I'm going to have to add 2 pi n. And then divided by 3, divided by 3. So theta is equal to a 7 pi. Divided by 3 is the same thing as multiplying by 1/3. So that's going to be a 7 pi over 18 plus a 2 pi n divided by 3. And then over here, I would do the last one, which is going to be, what is this angle? Well, again, all the way around circle is 2 pi. But if I'm pi over 6, which is my reference angle, short, that's going to be 11 pi over 6. So then therefore, I'd have a 3 theta equals a 11 pi over 6 plus a 2 pi n. And then again, divide by 3, and I get a theta is equal to an 11 pi over 18 plus a 2 pi n. All right. Now, RF, I have not gotten to your question yet because I think it's important to know how to get to this point, right? Because once you be able to identify those solutions, especially when you have restrictions or anything else, I think it's important. However, once you've graphed these points, and here's maybe the tips I would give you. Once you have these 3 points, if you see symmetry between them, then yeah, you're good. right? You know you can take this first point. Let's figure out what is the difference between these 2 points, right? So if I have a 7 pi over 6 minus a 1/2, now I did this from on there. I wonder if it's going to work in this case. So multiply by 3 over 3, 7 pi over 6 minus a 3 over 6, which is going to be a 4 over 6. That's going to be plus a 2/3, but I had that as a 2 pi over 9. Oh, divided by 3. Yeah. Okay. Yeah, sorry about that. Yeah, you get those are the answers before being divided by 3. So don't do that. Sorry. Okay. But I know, okay, so I'm looking at these points. Sorry. I was right in identifying symmetry. You see the symmetry, right? But everything got divided by 3. So crap, what is the new distance between these two? I know that they're going to be symmetrical. And if I divide all those angles by 3, they're still going to be symmetrical on that point. So what I need to do then is I need to determine what is the difference between these two. So I'll just pick 2 of them. What about we take an 11 pi over 18? You have to use the divided by 3 angle, not this original angle, right? Because these are not the answers. You had to take these answers, then divide it by 3. That's how you got your answer. So I'll do 11 pi over 3 minus a 7 pi over 3. Let's find the difference between these, or 7 pi over 18. And what you're going to get is a 4 pi over 18, which reduces to a 2 pi over 9. Okay, so that is going to be the equidistant between each of these angles from on there. And again, this is since they've been all divided by 3 in that case. And again, so now what you can do is that's what I would go through from on there. And then you can start with your smallest angle, which would be a right over here. So my final answer is theta equals a pi over 6 plus a 2 pi n over 9. And because that's going to be, I know, to the next point. And again, maybe you're like, I'm not really sure how that would 3 pi n over 9. And that would work in my case. So yeah, there we go. So hopefully that was a little bit helpful for you. Look for that symmetry. Once you know there's symmetry, then you can go ahead and use that as your simplified answer. So might not have been the best route from on there, but I think that's what I would, look out for as far as being able to see the symmetry between the 2 equations. So hopefully that was helpful. All right, let's go and see what you guys did for the thing. I got to run, but I want to see what you guys came up with the chat. Or the poll. Got to check on the poll. I don't do polls as much as I did. I got to do more polls. All good, A and B. Well, look at you studious people showing up on a live stream. Thank you so much, guys, for hopping in on my live stream. I greatly appreciate that. Look at 63% of you guys doing all good. Uh-oh. All right. Not sure why my screen died. I think my thing went through it. There we go. There we go. All right. Let's get back to that. That was really weird. I think my computer was just overloaded with doing the live stream for so long. So I apologize for that. Just had the blank screen going through. And I was wondering what's going on. All right. Well, I am going to peace out to you guys. Hopefully you guys can send your questions again to brianmclogan.com/Q&A. And I will see you guys on the next stream. And I look forward to doing more of your math questions. All right, guys. Peace.